In this video, I'll show the first step in solving the process synthesis problem using ProCAFD. Here, the first step is called as the problem definition step. In this step, the user defines the synthesis problem, and this is done by first selecting all the compounds present in the synthesis problem and then defining the inlet and the expected outlet streams. So for this video, I will use the example where we will be producing cumene from propylene and benzene. So we have two raw material streams representing propylene and benzene, and we have two product streams representing cumene and another side product disisopropyl benzene. So here we will also use propane as an impurity in the propylene raw material stream. So now first we will add the compounds from the database. So the first compound here is propylene. So here, once you search from the list of suggested compound, the user has to select and hit the add button. Now we also select the propane. Here the user has an option where he can also search with using the chemical formula or the class number. So C6H6 represents the benzene now, and the first product here is cumene, and the second product here is isopropyl benzene. So now we have selected all the compounds present in the synthesis problem. Now let's go and define the inlet and the outlet streams. We have two inlet streams representing propane and benzene, and we have two product streams, one for the cumene and other one for the disisopropyl benzene. Along with that, we have two more streams which are the raw material unreacted raw materials recycled streams. Now let's go and define the stream compositions of both inlet and outlet streams. The first one, as I said, is propylene. So by default it gives all the compounds. Now here the user has to give the composition what is suitable for the particular synthesis problem. Here in this case we have 95% of propylene coming in along with 5% of propane. So I will keep all the other compounds to 0. And now once you have done all your changes, one has to hit the save button to save all the changes what the user has made. The second inlet stream is a pure benzene stream, so I'll keep AB as 0 and C, which represents benzene, is kept as 1. I'll keep Z, cumene and the other byproduct as 0. So now once I've selected this, as you can see that the reaction tab had become red, which means that a reaction is required for these particular raw materials to convert into the desired products. So in this case, the first product here is cumene, which is represented by D. So I'll keep that as 1 and everything else is 0. The second expected product is isopropyl benzene, this isopropyl benzene, which is E, so I'll keep that as 1 and everything else is 0. Here I will say this is for unreacted propylene stream, and the last one represents the unreacted benzene stream. So now we have defined the inlet and outlet stream. Now one has to define the reaction data. Unless and until we define it, we cannot go to further into the next stage. So now let's go and define the reaction data. So one has to hit the reaction data, and you can see a new form will be appeared with all the selected components present in the synthesis problem, and here you can define it. So the first reaction here is 1 mole of propylene reacts with 1 mole of benzene to give 1 mole of cumene. So which is 1 mole, -1 represents it as raw material here, and plus represents it as a product. So the moment you keep the stoichiometric coefficients, you can see clearly what are the reactants and what are the products. Here I've kept the reaction temperature to be around 600 Kelvin and pressure is at 1 bar, and conversion of 0.75 with respect to say benzene, which is C here. And once you have given all the reaction information, you have to hit the save button. Here we also know that there is a secondary reaction, so where propylene reacts with cumene, give this of propylbenzene. Here is the reaction conditions are same, but the conversion is around 15% with respect to cumene. So here also I'll save. Now you can see that the reaction information is saved, and once you have completed all the set of reactions for that particular synthesis problem, one has to hit the close button and you will be able to see that the reaction tab has turned to green, which means that all the things which are required to solve the process synthesis problem has been properly defined. So the user can also see the problem definition here, where all the compounds present in the system along with the reactions, reaction temperature, conversions, etc. So the further steps in the process will be explained in the next video.